So, with law of sines, it is possible when you have side-side angle that there can be more than one triangle, depending on the information given to start. Because one side of the triangle can either, that angle can be acute, or it can swing, and that angle can become obtuse. So that's all dependent upon what's given, okay? So we're going to do 3 scenarios. Spoiler alert, they're labeled. Okay, so case 1 where there would be only one triangle, case 2 where there's 2 triangles, and then case 3 where there's no triangle at all, okay? So it's not that complicated to figure out if there's 2 triangles or not. So let's kind of take a look here. So first of all, you're going to solve what's given. Okay, so we are given this information initially. All right, so we're going to start with this and kind of fill in what we don't know. So we know to start, we're going to, we can use law of sines because we have one complete ratio, right? And then we have the side 23, which of course is across from big C. Okay, so we have to find angle C first because that's the information that we have to start. Okay, so we know that once we set up law of sines, we have a proportion that we can solve by cross multiplication. Now, when you are trying to find an angle measurement, you're going to be using inverse functions. Alright, so when I cross multiply, I don't want to cross multiply the 47. Why? Because I don't want sine C to have anything else around it. So I'm going to leave that 47 where it is, and I'm really just doing this. Okay. And in order to see what angle C is, you need to do the inverse, right? Of all of this. Now, I do not recommend that you do inverse sine and then try to type all of that inside. I recommend that you do in your calculator just this, and then YORO, right? Round 1 time, so don't give me a decimal, just do second sine inverse second answer, and you don't have to do any of that. The calculator will take care of all that for you, okay? So again, most of you are using the calculator. That's great. Okay, you should be trying to figure out the calculator on your own and not relying on your neighbor. Because when it comes to a test, you're not going to be able to look over at your neighbor and say, hey, what'd you get? Okay?
How do you input like your previous answer, like say into that second and the negative thing on the bottom?
So, well, you do 23 times the sine of 123 and divide it by 47, right? Did you do that?
Yeah, what? Yeah.
Did you do all that? You got some long decimal in your calculator right now, right? So if I want, this is not the decimal you have, but if I do second sine inverse, then second minus sine at negative sine at the bottom.
Oh.
See, it says ANS in blue there. Okay.
I just didn't know what
Yep.
the difference.
That's great. Now, that's good. Maybe someone else didn't know, so good. Okay, so when I do that, anyone get the measurement for sine, for angle C?
24.
Let's round to the tenths.
24.2.
24.2.
That's what the calculator said.
Awesome. Is the calculator right?
I'm not sure. I'm not the greatest.
What do we think, friends?
Yeah.
Okay, thank you. Appreciate those answers. Okay, now, step number 2 is pretty easy to find angle B. Right? Angle B is equal to 180 minus the other 2, right?
Yes.
So angle A plus angle C added together. So what do you get? Anyone get B yet? 32.8 degrees. Okay, good. So now we've got our angles that should add up to 180. And our last step then to solving this triangle is to find little b. So I'm going to go ahead and use the setup for A because that was given and I know I didn't make any mistakes with that, right? And then I found angle B to be 32.8. And then over little b. Okay, when you are trying to find the angle measurement, you are using inverse sine. When you are trying to find just the lonely side, you don't use inverse trig, okay? So we're going to cross multiply, and you don't need to write, bless you, you don't need to write out all of these things, but I highly recommend that if you want any kind of partial credit, you put something down on your paper, because otherwise I'm not really going to know what you're doing if you're just typing things into the calculator, okay? So you should be doing that in your calculator to get the side length for B. Okay. Anybody crunch the numbers? 30.4. Is that what I'm hearing? Okay. All right. Kind of hard to tell with the sides, right? Whether you have them right or not. So, but, you know, that looks okay. Good. Now, as far as the second triangle, up at the top, we just only did step 1, right? Solve the first triangle. So we're there. Now, it says take 180 and subtract from the first angle that we found. So the first angle that we found was C. Okay? So I'm going to take 180 and subtract 24.2. So do that for me. $155.8. Okay? Now, it says add the given angle to that angle. So what that means is it's asking you to add up 123 and 155.8. 278.8 degrees. Is that even possible in a triangle?
No.
No. You cannot have that, therefore that proves that we would only have one solution. Okay? The second triangle can't, remember, what I am saying to you is that one of these sides is gonna swing. Alright, it's like a door. Right now it's an acute angle, and if I want to swing it over to an obtuse angle by subtracting from 180, it can't make this bigger than 180. Okay? So that's not possible for this scenario. Okay? So that's option number 1. Okay? Option number 2. Same, looks the same, right? Spoiler alert, there's going to be 2 solutions. Okay?
What is the solution for number 1 then?
It's all of the solving the triangle is what
Just
it's saying when you find the solution. Okay? All right. Maddox, you okay back there? All right. Okay, so step number 1 is to solve the given triangle. So, of course, I've got one complete setup with A. So I've got sine of 35 over 12. I'm only given B, so I need to find angle B first. Okay? So I'll take some volunteers this time now that we've gone through one example. I think we can handle that. I'm gonna take a volunteer and then I'm gonna take someone to confirm. So Ari, did you crunch the numbers? Were you able to get angle B?
No, not yet.
Okay. Ben, how about you?
Yeah, I got 49.9.
Okay. So Ari, if you could just confirm, what did you say, Ben? I'm sorry.
49.9.
So 49.9 is what we're speculating right now.
Yeah, that's what I thought.
Okay.
Yeah.
Okay. So 49.9 is what you get for angle B. Okay. And now angle C, that's pretty doable, right? All right. So Nate, how about you give us angle C?
I didn't get that far.
Okay. Well, you're gonna get that far right now.
I'm doing it right now.
Okay. Because that one's an easy one, right? We've already got two angles of the triangle. Hello. Nate, what are you getting there?
I'm stumped.
You're stumped. You can't do 180 minus the sum of the other two angles?
Oh.
Jacob. And Corinne, could you do the numbers too so we can compare?
Yeah.
I was overcomplicating it.
Yes, you were. What'd you get?
95.1.
Okay. Is that what you got, Corinne?
Yeah.
Okay. There we go. See, we can do this. All right. So now we've got our three angles. So now all we need to find is the little C side. Okay. So again, I'm going to use the setup for A because I know that that is given. Okay. Little c is what I want to find, so I'm going to use the sine of 95.1. Okay, and then I'm going to crunch the numbers on that and find little c. Bless you. So again, I hope that we're kind of getting it a little bit as far as like how we cross multiply. So really, the 12 is going to come up here and these two are going to switch places. That's what happens through the cross multiplication process. All right. So Garen and Jack, what'd you get for an answer?
For C, I got 20.8.
I got the same exact.
Okay. I think 2 should be in the charm. No? 20.8. Okay. So now we have done triangle number 1, and we know the spoiler is that there's two solutions to this problem. So it says subtract 180 from the first angle that we found, which was B. Okay. So 180 minus 49.9 gets me what?
130.1.
Okay, and if you add up, okay, angle A plus B2, angle B2, sorry, what do we get?
165.1.
165.1, which is great because that's not past 180, which means that there is a third angle. Okay, so now I just have to, yep. And then, Sanaya, could you give us what the C2 will be?
You just take the C you already have and square it.
No, you take these two angles and you,
Oh, okay.
Yeah.
Never mind. 165.1.
no? You take these two angles and you subtract from 180. There we go, 14.9, okay? So those are the three angles that we have for the new triangle, the second triangle, because we have, we had an obtuse angle already for C, so there's the acute angle. Makes sense, right? And B was acute, and now it's obtuse. Okay? And then, just in case we're not sure, these are just notations to show which triangle is which, okay?
Wait, I thought, because the first problem we added the two together and that was the C squared or whatever. Why aren't we adding them together now? Because now it's.
We did not have a second triangle for the first example.
Yeah, but like we added the two angles that we found.
I added the two angles together, and then they were over 180, which makes them not possible to have a third angle in the triangle.
So now we're finding like the difference between 180 and
In our new,
our new.
whatever, in this case, our new
So this
B2.
between like 165 or whatever we got and 180 is 14.9.
Correct.
Okay.
Yes. Okay, so now we just need, because angle C is different, side C cannot be the same as the first triangle, so you do need to find, I don't really need to write steps anymore. So we have the sine of 35 over 12 is equal to the sine of 14.9 over little c, 2 if you want, to find that side length. Okay. Anyone happen to crunch the numbers already on that?
5.4.
5.4. Okay. So there are two triangles at times. And then this last example, friends, let's just quickly look at this because it takes only a second to set it up. When you set this up to initially solve the first triangle, okay, and you're trying to find angle B, so when I go to do this in my calculator, I'm going to do 20 times the sine of B, which is 20 times the sine of 50, and then I'm going to divide that by 10, okay? Now, that is what you are going to try to take the arc sine of, and sine's domain is from 1 to -1, -1 to 1, so that's outside of the domain. So when I do second sine inverse of my answer, it can't do it, okay? It's not possible because it's outside of its domain, okay?